All right. Okay, so here, let's keep going. So for the mean, you can't just add up the exam scores, okay? You can't just do that. I actually had that as a mistake on my notes before lecturing today. And that wouldn't be right because remember, you have to take the frequency into account. Okay, if you list, even if it's the same data value, if that appears in the data set, more and more often or less often, that will change the mean. So in other words, to get the mean, we multiply each value by the frequency. That's what I'm doing here. Right? You can imagine listing 15 10 times. And normally for the mean, you add up the data values, right? So you would be adding up 15 with itself 10 times. That's the same as multiplying by the frequency. And so on. So we're doing that for each one, 15 times 10, 25 times 12, 38 times 15, and so on. And then we also have to add up the frequency, because remember, that's how many data values there are. That's the size of our sample set, so to say. Or population, if it's all the elements of the population. That is, if it's data from every member of the population. So in other words, we have to add up the frequency as well. I do that here, the number of data values. You get 3,982 over 100, which is just this. That's the mean. You could do this in Google Sheets or Microsoft Excel. You could do that, even on the test. Well, actually, not this test, because this won't be on it. All right. Okay, before the next thing, are there any questions on this? Not just this slide, but this whole example, I mean. Okay. So we looked at measures of central tendency. That is, we tried to see, we looked at what could be considered the center, how we would find the center, and we saw mean, median, mode. Well, here, what we're going to look at now is measures of variation. Essentially, as I have on this slide, what we're going to do is consider how spread out the data is, how spread out, how much variation there is. That's what we're going to be looking at. And you can have two different data sets if they all equal this. If every data value equals the same number, there's no variation. You could easily get the mean. But you could have a data set where the numbers, the data value that is, varies a lot. And the mean could be the same as the other data set, but there's going to be, but we have to somehow consider that variation. Well, there's different ways of doing that. There's one I'm not really going to focus on, but it is mentioned in the book, called the range. And that's just the maximum value minus the minimum value. That's all. I'm not saying the range is necessarily worthless to consider, but it's not, from what I saw, it's not as useful as what we're going to look at shortly, called the standard deviation. We're going to calculate that. But this is just what the range is. I've seen also, I'm not sure if this is with variation, but I've seen what they call the mid-range. That's the average of, actually no, never mind. There's just the range. I'm thinking of something else. I'm sorry. The range. Now we're going to look at what's called the standard deviation. Standard deviation. All right. So what I'm going to do is first I'm going to write out how you actually proceed, how you calculate it. Then I'll demonstrate through an example or two. And as you would probably expect, having me as an instructor, I will give you an example to try. But this is the process for it, though. The first thing you have to do is you have to figure out what the mean is. We know how to do that. Then you're just going to subtract each data value from the mean. You're going to subtract each data value. This is on the next slide, so that's why I'm deleting it, from the mean. Each of those differences you're going to square. That is, you multiply by the number itself, and you add up the squares. Again, I know this is confusing, but again, when we do some examples, it will start to make more sense. So stay with me. You add up the squares. From 3, you're going to calculate a bunch of different squares. A number times itself, in other words. You add up those numbers. Now, here's the fun part. Depending on if the data you have is sample data or population data, that is, if the data you have comes from a sample only or comes from a whole population, that will determine whether you divide by n or n minus 1. N is how many data values you have, as you can see. If the data you have represents the whole entire population, you're going to divide by n. However, if it's just sample data, you divide by n minus 1. To be honest, I'm not 100. I mean, the only reason I could think of why statisticians do this is because they want the sample standard deviation to be bigger than the population standard deviation. That's all I could think of, to be honest. And again, the last thing is you compute the square root. Since you're adding a bunch of squares together, the sum will be a positive number. So the square root, it will make sense. And of course, for something like this, you're going to want to use a calculator. I guess theoretically you don't have to, but I would. I'm pretty sure the book goes into, actually, no, I take that back. I know the book does mention how to get the standard deviation using a TI-83 calculator. Again, I didn't require you to get one because I wanted to make the class as cheap as possible, so to say. But if you do happen to have one, you could use it as a check, so to say. Anyway, these are just some notes. Again, the first two from the previous slide, they were on the previous slide. That's what I deleted. Before you actually take the square root in this process, so basically before you complete step 6 and you've done the first 5 steps, you actually have computed what's called the variance. There is population variance and there is what do you call it? Sample variance. Can't think of the words right on the slide. And there's also sample variance. Okay. There's population variance and sample variance. Let me say it again. When you're calculating the standard deviation, before you take that square root, what you have calculated is what we call the variance. So in the previous slide, after you have completed step 5, before you've completed step 6, that is, you have calculated the variance. If it could be the population variance or the sample variance, but you have calculated that. It's not as nice as the standard deviation, for instance, in the sense that if you look at units, the units for variance are the units of the data values squared. So it's not the same exactly as the units for the data. The standard deviation it is, but not the variance. But the variance is still very useful, though. Also, number 3 here is really a convention that the book is following. So I'm going to follow it as well. Namely, we're going to assume that the data we're given is all sample data, unless we're told otherwise. In other words, we're going to be given, here's a bunch of data. Calculate the mean, calculate the median, calculate the standard deviation. We're going to assume it's sample data. So it's data from a sample of the population, not necessarily from the entire population. Okay. Now for mean and median, that kind of stuff, that's not really too much of an issue. But as we saw already with standard deviation, that does make a difference. If the population, you divide by n. If it's the standard, if it's on the sample, you divide by n minus 1. And again, is how many data values we have. Okay, let's actually start an example. So let's say we have this data here. So this data up top, let me circle it in pen. Actually, you know what? Before I do that, okay. As you can see, this is our data. So I just listed a bunch of numbers. I don't know where it comes from, but for now it doesn't matter. Again, it's sample data. Okay. So we're going to calculate the standard deviation. Remember, the first thing we have to do is get the mean. That's what I'm doing. There's 10 data values, okay? And we're calculating the mean. Right? We add them up. This is quantitative data, so we add. That makes sense. We divide by how many data values there are. And it turns out this product, the sum of these data values is 40, and you get 4 as the mean. Let me stop the recording. I pause the recording because if it goes too long, it won't. What's the word? It won't let me upload.